For the first step, I'm going to square both sides of this equation. On the left, it'll cancel the square root. And on the right, 3 squared is positive 9. If I subtract 9 from both sides, clearly the answer is x is equal to 0. For the first couple of questions, I'm going to really write out how I check the answers. You should do this for every solution you find. If it makes the original equation true, keep it. Otherwise, throw it away. But that process would be, go back to your original equation, and we're going to put x equals 0 into the left side, which gives me the square root of 0 plus 9, and we're asking the question, does that equal to 3? And the answer is yes, because the square root of 9 is in fact 3. So this is in fact a solution, and we'll keep it. If you compare this to the almost identical equation of the square root of x plus 9 is equal to negative 3, here, again, we're squaring both sides. On the left, you still get x plus 9. And actually, on the right, since you're squaring a negative, the negative goes away, and 3 squared is 9. After subtracting 9 from both sides, you again get x is equal to 0. But does this work in the original equation? If you take x equals 0 and put it in place of the left side, does it equal negative 3 on the right side? And the answer is no. The square root of 9 is not equal to 3. It is equal to 3, but it's not equal to negative 3. So those aren't equal, those aren't equal, those are not equal. This is not a solution. In fact, this equation has no solutions. So I won't do this for the remaining problems. That'll be up to you, but what you do is you plug in the numbers to see if they work or if they do not. All right, so for this equation, before you start squaring both sides, the square root portion has to be isolated. So I will subtract 2 from both sides. The square root of 2x minus 8 is equal to 4. I can now square both sides of this equation. And when I do, I get 2x minus 8 on the left is equal to 16 on the right. I'll add 8 to both sides, which gives me 2x is equal to 24. And after dividing both sides by 2, I get x is equal to 12. Now, I'll leave that for you to check, but this is in fact a solution to the equation. Similar idea for this equation. I want to get the square root by itself, so I have to subtract 1 from both sides. And this changes the equation to negative 4 is equal to negative the square root of 4 minus x. Now, as we talked about in class, the square root can't equal a negative number, but the fact that we have this extra negative means I could divide both sides by negative 1. I think it's going to mean there is a solution to this equation. So yes, a square root cannot be negative, but if there's an extra negative in front of it, I think the left and the right side can in fact be equal. If I divide both sides by negative 1, it'll cancel the negative. But what I'm going to do is square both sides because this will have the same effect. If I square the negative and the 4, the negative goes away, and 4 squared is 16. On the right side of the equation, if you square the negative, it cancels, and if you square the square root, you're left with 4 minus x. To solve this, I'm going to add x to both sides. I get 16 plus x is equal to 4. I'll then subtract 16 from both sides, and I get x is equal to negative 12. So negative 12 is in fact a solution to this equation. To solve this equation for x, again, I have to isolate the square root, so I'm going to add x to both sides. I have the square root of x plus 5 is equal to x plus 5. Now that the square root is by itself on the left, I'm going to square both sides. And I have to be careful here. On the left, it's simple. I get x plus 5. But if you square x plus 5, there's no square root on that. You square the first term. You do square the 5, which gives you 25, but you get double the product of the middle terms. So 5 times x is 5x, and if you double it, you get 10x. So we talked about this in class, but what I'd recommend is If you're having trouble with that, multiply x plus 5 by x plus 5 using FOIL. First, outer, inner, and last. You will arrive at the same thing we have here after you combine like terms. Anyway, we took this root equation to a quadratic equation, something with a squared in it. Our approach is going to be make this side equal 0. I'm going to do this by subtracting x and also subtracting 5. The equation becomes 0 is equal to x squared plus 9x plus 20. And I claim we can factor this thing. Okay, I need two numbers that multiply to 20 yet add to 9. That's got to be 4 and 5. And this means the two solutions are negative 4. Negative 4, when placed here, makes the factor equal 0. And likewise, x equals negative 5. It looks like we have two solutions. But the thing to recall is, do both of these work? So I'm going to check them in the original equation. Okay, I just plugged them in, and in fact, both do work. There are no extraneous solutions to this equation. Question 6 is set up for us to simply start by squaring both sides. On the left, again, I have to be careful here, but I get x squared, that's the first term squared. I get 1 squared, which is just 1. But if I take the product of 1 and x, I get x, and if I double it, I get 2x. There are 3 terms left over when you square the left side. The right side's simple. It's just x plus 21 because squaring cancels the square root. What I'm going to do is subtract x from both sides as well as subtract 21. And what we end up with is x squared plus x minus 20 is equal to 0. I think this factors. It's got to be x and an x. It's got to be a positive and a negative. It's going to be positive 5 and negative 4. The product is negative 20, yet those two numbers add to a positive 1. My solutions look like negative 5 and positive 4, the opposites that appear within my factors. Okay, this time both solutions do not work. It turns out that 4, that is a solution, so this one's okay. 4 is good. But if you put negative 5 into this equation, that does not work. It's an extraneous solution. Only 4 is the answer. All right, this one looks a little bit more complicated, even though we are taking the same approach of squaring both sides in order to cancel the square root. Okay, on the left, okay, 2x squared, 2 squared is 4, and x squared is x squared. If I square 5 at the last term, we get a positive 25. Now the middle term is going to be, well, 2x times 5 is 10x. If I double that, I get 20x. And on the right side of this equation, I just get 4x plus 109 because we are squaring the square root and those cancel each other. So I'm going to subtract 4x from both sides as well as subtract 109. My equation becomes 4x squared plus 16x, and then we get negative 84 is equal to 0, right? Yeah, perfect. All right, I want to factor this equation. I can take out a greatest common factor of 4. That's common to all 3 terms. If I do factor out a 4, I'm left with x squared plus 4x, and then 16? No, 21, minus 21. That makes sense. All right, so I factored 4 out from every single term. That was the greatest common factor. I did this because, all right, it should be easier for me to factor apart what is left over in the parentheses. We have to have a positive and a negative. We want two numbers that multiply to a negative 21 but add to a positive 4. Okay, it's got to be 7 and 3. The sum is positive 4. The product is negative 11. Therefore, my two potential solutions are x is equal to negative 7 and x is equal to positive 3. Do both of these numbers work in the original equation? Okay, I plugged them in, and no surprise that -7 did not work. -7 is an extraneous solution, but when I plugged in 3, that made the left side equal the right side in the original equation. So again, I'm not plugging it back into the thing with the square in here. I'm plugging it into the very first equation that appears on the homework. This one did not work, but this one made the left side equal the right side. In question 8, this is not solved for the square root, so I'm going to add 1 to both sides. My equation becomes the square root of x plus 421 is equal to x plus 1. I can now square both sides since the square root is isolated. On the left, it's simple. I get x plus 421, whereas on the right, if you square x, you get x squared. If you square 1, you get 1, but you double the product of the two terms. 1 times x is x. I double it and I get 2x. I'm now going to subtract x from both sides, as well as 421. And when I do, I get 0 is equal to x squared plus x minus 420. Okay, this should factor. I need two numbers that multiply to 420 yet add to 1. Just making some guesses here. It's got to be 20 and 21. I figured they'd have to be relatively close together, and I knew 20 went into 420, so that's x plus 21 and then x minus 20. The product is 420 and the sum is positive 1, which means my solutions are negative 21 or positive 20. Do both of these work? All right, so it turned out that negative 21 did not work in my equation, but positive 20 did. So there's only one solution to this equation. For the rest of the homework, we're going to be using the quadratic formula to solve these equations. And for question 9, I want to solve x squared minus 6x plus 8 is 0. So even if you can factor it, I still want to have some practice with this equation. What we need to know is what is a, what is b, and what is equal to c. Your equation has to be written so one side is equal to 0, and a is the number from the x squared term, b is the number from the x, and c is the number all by itself. So right below here, I'm going to say a is equal to 1, b is equal to negative 6, and c is equal to positive 8. Going directly to my formula, the solutions to this equation are negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And all I need to do is simplify this expression. I get negative is just positive 6. The square root, I'm going to do this in my calculator. So negative 6 squared minus 4 times 1 times 8 is 4, and this is all divided by 2. The square root of 4 is 2, so I'm going to put 6 plus or minus 2 over 2. This means there's two solutions. I'm going to write them separately. We have 6 plus 2 over 2 and 6 minus 2 over 2. The one up here is 8 over 2, which is 4, and the one down here is 6 minus 2, which is 4 over 2, is 2. There are two solutions, 4 and 2. So again, just to recap, I identified A, B, and C because one side was equal to 0. I put all the information into here, and I simplified it. Once I got to this portion where there was a plus or minus, I split it into two separate pieces with a positive and a negative, and followed order of operation to reduce it down to one number. All right, so this expression here in 10 is not set equal to 0, so I first have to write this as x squared plus 2x minus 15 is equal to 0 before identifying that a is 1, b is 2, and c is negative 15. Going to the quadratic formula, I get negative b plus or minus the square root of b squared. Here, because b is a positive number, I don't have to be careful with parentheses. But anyways, b squared minus 4 times a times c, being careful with parentheses here, because I'm multiplying several terms together, all divided by 2 times 1. If I simplify this, I get negative 2 plus or minus the square root of, and I'm going to do this portion in my calculator. 2 squared minus 4 times 1 times negative 15 is 64. All divided by 2 times 1, which is 2. And the square root of 64 is an integer, which is 8. There are two solutions to this equation. Negative 2 plus 8 over 2, but also negative 2 minus 8 over 2. This one here is 6 over 2, which is equal to 3. And this one is negative 10 over 2, which is equal to negative 5. Those are my two solutions. This quadratic is set equal to 0, but I'm going to rewrite this so there's actually an x term in here. That is, this is really x squared plus 0x minus 100. That way, you can more clearly see that a is 1, b is 0, and c is negative 100. Going to the quadratic formula, we get negative 0 plus or minus the square root of 0 squared minus 4 times a times c, all divided by 2 times a. Okay, the first part is gone. Negative 0 is negative 1 times 0, which is just 0. So this is plus or minus the square root of, and in my calculator, you can do this in your head too if you'd like, that's 400. And that's all divided by 2. The square root of 400 is 20. So here we have two solutions. It's going to be 20, a positive 20 over 2, or a negative 20 over 2. Here I get 10, and here I get negative 10. For this question, a is equal to 1, b is equal to 20, and c is equal to positive 96. We get from the quadratic formula negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a will give us the solutions to this equation. Okay, so we have negative 20 plus or minus, let's see, 20 squared minus 4 times 1 times 96 is 16. This is all divided by 2. And the square root of 16 is 4. And so here we have our two solutions. We have negative 20 plus 4 over 2, and also negative 20 minus 4 over 2. In this first one, that's negative 16 over 2, which is negative 8. And then we have negative 24 over 2, which is negative 12. In question 13, a is 2, b is negative 11, and c is negative 6. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Okay, our two solutions are going to be positive 11 plus or minus the square root of, 11 squared minus 4 times 2 times negative 6. That's 169, all divided by 4. And I think, again, we have a perfect square under the square root. So we get x is equal to 11 plus or minus 13 over 4. So we've got to be careful with our two solutions, but it's 11 plus 13 over 4 and 11 minus 13 over 4. Okay, in this first fraction, we get 24 over 4, which is 6. But in this one, we get negative 2 over 4, which is negative 1/2. So these are the two solutions to the equation, 6 and negative 1/2. In question 14, I have to add 17x to both sides. And I want to be careful here that I put that between the x squared term and the constant term. The equation is 3x squared plus 17x plus 10 is equal to 0. So here, a is equal to 3, b is equal to 17, and c is equal to 10. The solutions are going to be negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Okay, that's negative 17 plus or minus 17 squared minus 4 times 3 times 10. It's 169 again, all divided by 6. So that's negative 17 plus or minus 13 over 6. Our two solutions are negative 17 plus 13 over 6, and also negative 17 minus 13 all over 6. Okay, the first one is negative 4 over 6, but then we can reduce this to negative 2/3. There's one of my solutions. This one is negative 30 over 6, which means the other answer is 5, negative 5. Those are the two solutions to my equation, negative 2/3 and negative 5. In this equation, a is equal to 4, b is equal to negative 8, and c is equal to negative 5. Since this is already set equal to 0, my solutions are negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a, which when I simplify this gives me 8 plus or minus the square root of, okay, so negative 8 squared minus 4 times negative 5 gives me 144, all divided by 8. And that's 12 under the square root. And I have two solutions again. I have 8 plus 12 over 8 and 8 minus 12 over 8. Okay, so this first one is going to be 20 over 8, and the other one is negative 4 over 8. This reduces to negative 1/2. That's one of my solutions. And for this other one, the greatest common factor between them is 4, so this is going to be 5 halves. Those are my two solutions, 5 halves and negative 1/2. I'm going to start this problem by adding 2 to both sides and making sure to put that 2 at the very end of my equation. 15x squared minus 13x plus 2 is equal to 0. Because a is equal to 15, b is equal to negative 13, and c is equal to positive 2. The solutions are going to be negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. This simplifies as positive 13 plus or minus the square root of, okay, negative 13 squared minus 4 times 15 times 2. It's 49, all over 2 times 15, which is 30. Here I have 13 plus or minus 7 all over 30. I have two solutions, 13 plus 7 over 30 and 13 minus 7 over 30. Okay, for the first one here, that's 20 over 30, which simplifies to positive 2/3. That's the solution. All right, and then for this other one, we get 6 over 30, which both share a common factor of 6, which means I get 1/5. My two solutions are 2/3 as well as 1/5.